Hi everyone, Matthew Doyle here. Today I'm going to be showing you guys how to take a character from concept and model sheet to 3D model and then rigging and animating that character inside of Maya LT. Now Maya LT is a new indie-friendly 3D modeling package that uses the same code base as AAA 3D modeling software Maya, used by lots of movie and game studios in the industry. Maya LT is designed to be a simpler and a very powerful tool for creating real-time game assets, including environment art as well as characters. And it has everything you're going to need to create those objects, including polygon modeling tools, texture mapping tools, animation tools, all with the same power and code base behind it that Maya has. And so let's go ahead and get started. I'm not going to be able to show you everything today in the 45 minutes that I have, but we are going to kind of go through the most important steps in creating your character and talk about some possible tips and tricks that can help you speed things up. And by the end of this class, we'll have an actual animated character. So what you see on the screen here now is my model sheet created for this character Sven. And I've got a front view and a side view. So we've got our front view, our character in a T-pose, and then our side view. You'll notice that in the side view I've cut off his arm so that it doesn't get in the way of seeing the rest of his body. And also we want to make sure that both the front view and side view share the same dimensions. That is, they have the same height, the same basic shape. Everything is in the same basic location, so that when we're using the model sheets inside of Maya LT, we're not going to run into any kind of scaling issues trying to model him from the side versus the front. And I built this model sheet inside of Sketchbook Pro, which is a very good program for creating concepts and model sheets like this. And when we're all said and done, we'll jump into Maya LT and we'll be able to see our character here, Sven, fully modeled. And here we have him animating some kung fu movement from some actual motion capture data thanks to human IK. Alright, so before we can actually begin modeling our character, we need to bring in our model sheet to help us to visualize what our character should look like. And what we're going to do is we're going to start with the front viewport down here, and we're just going to go to our view menu, image plane, and import that image. So we're going to choose the front view. Alright, so we'll go ahead and just bring that guy a little bit closer here so you can see him. He's way too small for what we want to do here. If we go to the attribute editor and then scroll down a little bit, we're going to find the actual height is 10 centimeters. And what we need is something closer to 6 feet tall, which is around 180 centimeters. But I know there's some bleed on the top and bottom of this image, so I'm going to go ahead and set it to about 195 centimeters to account for that. Okay, and so that should give us about a 6 foot tall guy there. And what we're going to do now is we're going to position him so that his feet are right on this grid line in the front viewport. And to do that, we're going to go back to the attribute editor with our image plane selected. Scrolling down, and we should find an image center here, and these values represent the X, the Y, and the Z. And what I need to do is I just want to change it again so my feet are on that grid line. So I'm going to change the Y value, and in my LT, Y is always pointing up. We're going to change that to about 93. And so now my feet are pretty close to being right on that center grid line. All right, so I'm going to do the same thing now for the side view over here. Now you'll notice in the perspective view here we have the image planes as well, and we're going to actually hide them in the perspective view. We don't need them there, but before we do that, I want to move them so that they're not centered like this on the origin in 3D space being the location right in the center of your scene. It's called 000 or the origin. Now I'm going to move my side view so it's further over to the left, and I'm going to move my front view so it's further to the back, creating kind of a box around where we're going to model our character. So now we have our nice little image plane box set up, but we don't need it again in the perspective view. We only really need it in this side and front view. So we'll go to Show at the very top of our perspective viewport, and we're going to turn off image planes right here. Okay, so using the polygon shelf, I'm going to just click on the cube here, and then we'll go ahead and zoom in using the scroll wheel and middle mouse click to pan our view, and we'll just go ahead and draw the box right here, right around the waist, and it will set the height. Now I'm going to jump back into perspective viewport here, have a look at our object. Looks about right in the top as well, looks about right for the thickness, but this is where we have our side view model sheet. If we go to the side view, we can see that it's not quite where we want it to be, so let's just kind of move it here. Now we could center it and then scale it. So if I press R to go to scale, I can drag just this handle here to scale it. That's one way to change the shape of the object. Or I could go into vertex mode by right clicking, choose vertex, drag and select all of those verts. You'll notice that it looks like I've only selected these two verts, but if we go into perspective mode, we can see that I've actually selected all of the verts on the back side of that object. Alright, and now I'll just use the blue handle here, press W to move, and then we will move those guys into position. And then once again, we'll move these guys a little further out to match his belly. Alright, so now what we need to do is start to extrude the shape or the top of that to create the next part of his torso. So we'll go into face mode by right clicking and choosing face, select that top face, and then all we need to do to extrude it, I'm going to zoom in a little bit here, and I'm going to zoom in a little bit here as well. Now I'm going to use the marking menu here. I'm going to hold down space, go to edit mesh, and choose the extrude tool. Now my gizmo is a little small here, and if I press the plus button on my keyboard, I can actually make it larger so I can get a better, less cramped look at my gizmo and get access to all of the different parts of it. We can see here on the gizmo I have a scale, I also have the translate, and what I need is the translate. So I'm just dragging that blue handle up in the Y direction. If you look in the front viewport down there in the bottom left, you can see what's happening as I drag it up. I'm just going to drag it right up to the bottom of that belt there. And now I'm going to scale in the front viewport here, bring it out so that it matches his body. And then in the side, I'm going to do the same thing with the green handle. I can also move that a little bit. Alright, and now we can extrude again. Simply press the G key to repeat the same command, and now we'll extrude up again in the perspective. I'm also going to stop right around the belt area here. Scale that out again in the front, and we'll just do the same thing in the side again, and rinse and repeat. Hit the G key. We're going to go all the way up to right around the armpit. Scale that out. Same thing in the side here, just kind of match it up. Now you can see here we're not getting a perfect match to the rest of his back. That's something we'll adjust later on using the polygon modeling tools themselves. And then we'll repeat our command using G. Extrude up all the way this time. We're just going to go up to the shoulder here. And in this case, we're going to scale it in just a little bit. And then we'll scale it in the side here considerably. Alright, so that gives us a basic shape for our torso, a nice little box shape, and obviously this is nowhere where we want to be unless we want our character to look like a robot. So we're going to need to do a lot of work here to add some detail to our body. Real quick, you'll notice that in my front viewport we're getting a really nice effect here where my polygonal object is actually being overlaid or drawn on top of by the model sheet, so it really helps to visualize, whereas in the side view here that's not happening. And the problem is that if you look in the top viewport here, the model sheet is actually in front of, so this is where our front view camera is coming from, the bottom of the top view. So it's actually in the front of our model, whereas the side view image plane is on the left side of the model, and the side view camera is coming from the right side of the top here. So what we need to do is I'm just going to grab that image plane here in the top view, and I'm going to slide it this way. And now we get the exact same effect here on the side, so we can actually select our polygonal object, modify it, and still see our model sheet behind it. Alright, so in order to start adding some detail to our torso, we need to add some more segments to our object here, because this is as far as we can take this box model at this point without starting to cut it up. Now, there's a couple of ways we could go about this. We could use a marking menu and go to Edit Mesh, and we could use the interactive split tool. But what I'm going to show you today is a much better workflow that I like to use, and it's using the modeling toolkit. So to use the modeling toolkit, we'll use this top button up here on the top right of my LT. It's this one on the far left, modeling toolkit, and that will bring us up to the modeling toolkit panel. And I'm not going to explain everything about the modeling toolkit. That's another class. But what I want to do is get right into using it using the quick draw command here. The quick draw command at the bottom here on the right, if we turn that on, that's going to enable us to very quickly and easily begin to move around vertices and edges on our object, as well as adding new edges and so forth. Because what we need to do now is we need to begin to shape this to look more like a human body and less like a box or a robot body. And we need to do that. To do that, we need to add some edges. But first of all, you'll notice that as I move around on the object with quick draw enabled, it's highlighting the edges and the verts and the faces that I mouse over. And so I can actually work using a multi-component select, which you'll see at the top here, multi-components enabled, or I can just disable this and only work with edges or verts or faces or so forth. So I like multi-components, so I'm going to keep that enabled. And if I control middle click on an edge, it'll drag it around. Likewise, I can middle click on a vert, it'll drag it around. And in likewise, same thing with a face. I can actually modify the shape of the object in that way. I can also hold down Shift, and as I hold down Shift, you'll see that I can actually add edges to my object based on where I move my mouse. So if I move my mouse right here on this edge, you'll see that it wants to add an edge ring that goes all the way around the object. If you look in the perspective view, you can see the highlighting going all the way around the object, so we can add some detail in that way. Likewise, if I put my mouse over these side edges, it does it along the horizontal axis or along the vertical axis of the object instead. Alright, so what we want to do is start simple. We're going to go ahead and add a center line. Now eventually we're going to cut off one side and just work with the other side, and then we can always mirror the work we do to the other side. That way we don't have to do double the work, because most of this model is symmetrical, and so we can very easily do that instead of trying to model this side then model that side and so forth. So let's start right now though by adding a center cut line. So we're holding down Shift, and I'm going to just left mouse click right there in the center or thereabouts and that allows us to create that center line. Alright, now before we add any more edge rings, let's go ahead and make some adjustments here in the viewport. And so what I'm going to do is I'm just going to go ahead and select the side edge rings here of our body, and then I'll just drag those back a little so that we round him out some. So you can see in the side view there, we're kind of rounding out his torso a little better. And the same thing with the back. So I'll select the top, then Shift double click the bottom edge, and that will select the entire selection of edges between those two. And then we'll drag those in a little bit. Now you notice here we've got this piece around his neck, this armor plate. This looks like the base of his helmet. That is going to be modeled as a separate piece, so we don't have to worry about that part. However, these belts, we're going to keep those as part of his body, so we're going to need to cut some actual edges to match up with the shape of the belt. To do that, we can go into our multi-cut tool inside of the modeling toolkit, and then all we need to do is start cutting. So we'll just we'll do a cut right here, then a cut right there, and we'll come up here and we'll create a cut. And after we've done all the cutting we want, we'll just hit enter, and that will create the actual cut for that. And so likewise, we're going to continue doing some cuts here for the bottom belt. Hit enter, and we're going to start here, cut here, hit enter, and then we'll just keep doing that until we have the basic shape of our belt. Now I know this belt needs to go across to the other side. Hit enter. Alright, let's go ahead and continue cutting the belt here. I am going to show you now just quickly how you would use the extrude tool in the modeling toolkit to bring this belt out. So we'll turn on the extrude tool. And the great thing about the extrude tool is that you can just start to extrude right out of the gates here just by dragging on the faces that you want to extrude. But that's not what we want to do. We actually want to select the belt faces first. So let's turn the extrude tool off and go ahead and select our belt faces, holding down shift. We'll turn on extrude, and now when we do our extrusion, it extrudes all of the faces together. So we'll just bring them out to about right there. Now, one important thing to keep in mind when you're building assets for game characters or movie characters for that matter is that you want to keep a clean topology. That is, the edge flow of your model, where the edges move across your model, should be very clean. They should be evenly spaced in a grid-like pattern. They should also match the overall shape of the musculature, the anatomy of the character, and they have to be set up in such a way that when the character is animated, his body deforms, it doesn't create any strange issues. Now, another thing to keep in mind, and that this will help with keeping a clean topology, is to try to keep all of your polygons on the object as quads or squares. No triangles, no five-sided polygons. Everything, if at all possible, should be a quad, a four-sided polygon. Now you see here I have a big quad on each side of his chest here under the belt. Obviously we're going to subdivide this even further, add some more detail, get a nice evenly sized amount of quads on his entire body. But also, if you look, I've got this very irregular polygon here, so we need to definitely break this up into quads. Now, one way to do that, we'll just go to multi-cut and figure out how we can break this shape up into quads. And now I can see it, maybe you can see it too, but really all we need to do is we need to do a cut from here to here. We'll go ahead and hit enter, and then do a cut from here to here. And now we have, if we turn off multi-cut, we can see here we have 3 four-sided polygons. Perfect. Let's do the same thing to the other side just to repeat the process. Again, so you can see here what I'm doing is I'm duplicating my work. That's kind of in a production environment, not something you're going to want to do. Normally, by now I would have already cut off this entire side just by selecting all the polygons. Like, let's see, let's go into face mode. So we'll right click and choose face. We'll just draw a box around it, selecting that entire side, hit delete, and now we'll just work with that side. So we don't have time to model the entire character, obviously, but I want to show you just a couple more tricks, and then we'll move on to rigging. I want to show you how to start an arm and then combine the arm with the torso using the bridge tool, and then I'm going to show you how to use the modeling toolkit to begin laying out the edge flow and the polygonal placement of the face. So let's start out with the arm, since it's a little bit simpler to do. And what we need to do is we need to create basically a cylinder to represent our arm, because after all, the arm is a cylindrical shape, and I like to start with an octagonal cylinder. That's a cylinder with 8 sides. So in order to do that, we're just going to go to our side view here, and we'll go ahead and click on our cylinder, draw out the basic shape of it here to kind of match our model sheet, and then drag again to create the length. Go back to the perspective view. We can see it there. Let's go ahead and go to our front view and drag it into place over here. Alright, so obviously it's much thicker than it needs to be, so we can just go over to the channel box, or I should say the attribute editor, or go to our poly cylinder here, and you can see the radius value there. We can just reduce that so it matches up with our character's arm a little better. Alright, now we're also going to need some segments down the center so we can make some changes there. So we'll just go to subdivisions height, and we'll change that to, let's just set 8. And that's probably too much for now. Let's go with 4. Always work small and simple to begin with, so you don't have as much work. We could even start out with 2 if we wanted to and just create the basic shape here by, we'll go into vert mode, so right click vertex, select all those guys, go to scale using R, and then just pull that out a little bit so it kind of matches the shape of his bicep. Likewise, we can grab these end verts here, and then using the move tool, that's W on the keyboard, just bring it back right about to where the elbow is. Likewise, we can do these, go back to scale, and then just kind of match it up there. Alright, now we've got way too many segments to work with for now. Like I said, I like to work with an octagon shape. So we'll go back to object mode, and we're going to, under our poly cylinder, we're going to change the subdivision axis from 20 to 8. Now you'll see what happens when I do that. We can see that it's distorted. The center points here come to a point. The verts on the other edge are all messed up. So that is a good indication that we should have probably changed the subdivisions before we modified the verts, the shape. So let's go ahead and do that now. Change our subdivision axis to 8. And now we'll go back into our front view and remodify those verts. So, good tip there. Make sure you have the right amount of subdivisions that you want to use before you begin to modify the shape of the object, because you may get unwanted results. Alright, there we go. Good enough. So we have the beginnings of our arm shape, and what we want to do, go back into object mode, we want to actually combine these two pieces here. In order to do that, we're going to need to first get rid of the cap of our cylinder here and then create a hole inside of our torso. So let's go ahead and go into face mode. We're going to select all of these guys on the cap just by shift selecting each of them, all these faces here. Hit delete, create a hole there, that way we can continue the arm that way. Now you may be wondering, how are we going to extrude out if we don't have faces? We can always extrude edges. So if I were to select these edges here, I'll just double click that, and that will actually select the entire ring. Now I can actually hold down shift, drag, and I've created new faces. Likewise, you can use the extrude tool on edges. So we're just going to cancel that out for now and continue on with connecting our arm to the torso. So once again, we need to select all of these faces here and delete them. Alright, so now the arm's ready. We just need to create an octagonal cutout on our torso that matches up with the arm here. Now, before we do that, let's go ahead and adjust this back face a little bit so that it doesn't have any overlap issues there with the arm. We can always make some corrections later. Alright. Likewise, I'd like to bring this edge down so that it doesn't interfere with what we're about to do. So I'm just going to drag it down. Okay. Now we just need to cut out our hole here in this face. Alright, so I think you guys probably know where I'm going to go with this. I'm going to use the modeling toolkit again, my favorite tool. I'm going to select this torso here, bring up the modeling toolkit, and I'm going to use multi-cut. Now what we're going to do is we need to create the hole here, and the hole is obviously 8 sides, so we need to create polygons that will support the shape of that hole. To do that, I'm going to start from the top here where the neck is. I'm going to create a cut from there down to the armpit, hit enter. Then I'm going to take a cut from the chest, the center of the chest here, towards the back, right there. Well, let's start from the back and then go to the chest. There we go. Alright, so now we have the ability to create cuts from these segments. So if I just create a cut there, down to here, and then create a cut from that point up to about right here, and then just continue around until I have the entire shape. Alright. Now you'll notice that we have some edges here that terminate and create ingons below them. This is an ingon over here and so forth around the back, but don't worry, we can always extend these edges by simply creating the cuts later. I just want to focus on this arm for now. So we're almost done. We've got a 4-sided hole here that we can create, but we really need 8 sides, so all we need to do is create a cut here, and then I'm going to just, for the time being, I'm going to terminate it there. Likewise, we'll do it over here. And up here. And finally here. Alright, now we'll go into face mode, turn off multi-cut, and we're going to select these faces here, and we can delete them. So now we have our hole. We just need to kind of match the shape up here. So I'm going to go back into vert mode and we're going to move these into position. Just roughly moving them into position here for the sake of time. Alright, so obviously there's some issues there. Some of the verts are sticking out and whatnot. That's something that we'll have to fix at some point. But for now, we have our hole, and now we can actually bridge these two pieces together. So to do that, the first thing we need to do is combine these two objects into the same piece. Right now they're separate actual meshes. So I'm just going to select the torso, select the arm, go into my mesh menu and choose combine. So now if I go into object mode and select the torso, it also selects the arm. Now I'm going to go into edge mode and select the edge ring on the torso by double clicking an edge there, and then likewise do the same thing on the arm. And now if I go into the edit mesh menu and choose bridge, we can see there that it bridges the two pieces together. Unfortunately, it did so by adding quite a few segments there that we don't need. We really only need one segment. So let's repeat that by going to the bridge command, but this time instead of just clicking bridge, we'll click the actual little square here. That means to bring up the bridge options. We can see here divisions is set to 5. We'll just set this to 1, hit bridge, and now we have it with just the 1. However, in this case, I think it's safe to say we only really need 0. There we go. So it's a direct bridge. Alright, so that pretty much covers connecting the arm using the bridge tool. We can't go into too much more detail now on making his body look better. We just don't have the time. So let's go ahead and move on. And then I'm going to go ahead and unhide our final version here of our model. Now my LT has several ways to texture objects. One of them is shader effects for creating real-time OpenGL and DirectX 11 shaders that run on GPUs. That is a very cool tool and a very interesting topic to cover, but unfortunately I'm not going to be covering that today. So here we have our final textured model using the DirectX 11 Uber shader. You can see we've got some very nice reflective and specular highlights on the jetpack, as well as some glowing emissive parts. Likewise, the body has a normal map and specular. So this is our completed textured modeled Sven. So rigging our character for animation first requires that we add a skeleton. Just like a human has a skeleton, our character needs a skeleton. So we're going to go to the animation menu, and in here we'll find a skeleton menu. Now the tool we're going to use is called the joint tool. There's a couple of ways we could add a skeleton actually. Before we use the joint tool, let's look at the human IK way. So down in the same menu we'll find human IK. And in the human IK panel here, if we were to simply create a skeleton by using the button here, I'm going to go into wireframe mode. You can see that the human IK skeleton here, if I select it, has already been created to pretty much match the body. So it's really close to the size of our character. And we can then actually modify this from human IK by simply changing the sliders here in the human IK skeleton panel. We could change the number of spine joints from say 3 to 5 or down to 2. Likewise, we could increase the neck bone count to 2. We could change the number of fingers, the number of toes, so forth and so on. And we can also go in here to each bone and move them around into position. But what we're going to do is we're going to use the joint tool. So in order to use the joint tool, I'm going to jump into the front viewport here. I'm going to turn off my image plane because we don't need it anymore. Alright, and I'm also going to go into untextured mode, and I'm going to turn off the grid because that really annoys me. Okay, so using the joint tool, rather than just clicking on it, we're going to bring up the joint tool options so we can see the actual tool settings, because there's a couple of settings here that are pretty important to take note of. First of all, we have a symmetry setting, and symmetry is going to allow us to work with just one side of the body, creating the joints, and then it's going to automatically create the joints on the other side for us. Finally, we have projected centering, and this is not necessarily enabled by default. And what we want to do is, with projected centering turned on, it's going to allow us, as we create the joints, it's going to actually center them inside the body. So if I were to turn it off and say start to click to create my joints, now symmetry is working, But you can see here that if I move around the object in perspective mode, the joints were not created inside the body. So we're going to undo that. Go back to the front viewport, turn on projected centering, and I'm going to start with the shoulder right about here. All right. And now in perspective mode, when I go to wireframe, you can see that the joints are actually inside the body. Alright, so just like a cooking show, we've got our final pre-baked version here with our completed skeleton. Now that we've got our skeleton properly laid out, we need to actually basically connect the skeleton to the mesh so that it actually deforms the mesh when we move the skeleton. Because right now, you'll notice that if I move the arm here, nothing happens to the mesh. So this is where skinning comes in. So in order to do that, we're just going to very quickly and easily in my LT select our skeleton and then select the mesh. In this case, we're only going to work with the body. And once again, under the animation menu, we'll go to the skin menu, bind skin, and I'm just going to hit smooth bind without the options. And it's already done. It's that fast. And now if I select this bone and rotate it, we can see that, well, the gear is not moving, but that's because I didn't bind the gear. But the arm is, in fact, animating. Now, you might notice that there are some issues here to the armpit, and this is pretty common. So if I were to select the armpit, you can see that there's some kind of bad deformation there where the arm goes down, and that can definitely be fixed in a number of ways. Now, in order to do that, we'll go back to the skin menu, edit smooth skin, and we're going to go to the paint skin weight tool. And so inside the paint skin weight tool, we can see all the different bones that are affecting our mesh. So in order to begin fixing the armpit, I'm just going to go ahead and select the arm bone. Now, it's kind of a pain to scroll through here and try to find it, or maybe you remember the name, you can type it in up here. But another really easy way to select the bone that you want to work with is simply to right-click on that bone and choose Select Influence. So now we can see right away that the influence of that bone there. And so now all we need to do is use the Paint Skin Weights painting tool to actually apply the influence more evenly between the joints of the shoulder until we get the result that we want. Let's look at, just briefly, the difference between forward kinematics, inverse kinematics, and then we'll talk a little bit about constraints, how they can help you in your animation. So forward kinematics, put simply, is the act of animating from a parent bone to a child bone. So I would take the shoulder here, move it, then I'd move down to the forearm, rotate it as well, and I would just keep proceeding that way until my animation was complete. Whereas inverse kinematics is the opposite. You take, say, the hand joint here, and then you move it, and that would move all the bones up to the parent, the termination point, say the shoulder. But I don't have inverse kinematics set up on this guy yet. As you can see, nothing's happening where it's distorted. So in order to set that up, we have a tool called the IK handle tool. But before we do that, let's go ahead and make our workflow a little bit easier to handle. And we've got, see here, the mesh on a different layer. So I'm just going to turn that to a template layer so that I can't select it, but I can still see where it's at. And now all I can select are the bones. Alright, so let's go ahead and go to the skeleton menu, IK handle tool, and let's bring up the options for it. Where it says current solver, we want to make sure that's set to rotate plane solver in this case. Alright, so I'm going to select the first joint, the wrist, and then I'm going to select the termination, which is the shoulder joint there. And you can see that it creates this green line connecting them directly, as well as green line running down the joints. And that is an indication that we have an IK solver in place. So now we can see I've already got my IK handle selected. If I were to go ahead and just move it around, you can see the effect there. In fact, we'll go ahead and turn this back to normal. And we can see very nicely how easy it is to animate the entire arm just by moving the wrist around. Alright, so that's basically how to set up IK. Now, sometimes when you set up an IK solver, it doesn't provide as much control as you'd like it to have. Specifically, in this case, the elbow might need more control. There might be a position where we move our arm to that creates a very unnatural location for the elbow to be. And this is where constraints can help to provide more control to your rigs. In this case, we're going to add what's called a pole vector constraint. Before we can add our pull vector, we need to provide a control object. Control object can be anything, a cube, whatever. And I like to use curves. A lot of people like to use curves. So we're going to go to the front viewport here and go to our curves menu. And I'm just going to create a circle right there behind the elbow. And in the top view, we're just going to drag that circle so that it is back behind the elbow. Now actually, what I'm going to do is I'm going to snap it to the elbow, and I'm going to do that by holding down the V key and middle mouse dragging it directly to the elbow. And that's going to snap that curve so that it is centered on the elbow. In fact, if we go to the front viewport now, we can see it is also centered there. So now that I know it's perfectly centered, I can just drag it straight back, and I know that it's perfectly aligned with that elbow. All right? So now we can select the circle, which we already have. Then we'll select the IK handle. I'm going to select it here inside of the outliner. We'll go to Constrain and simply choose Pull Vector. And now we've added that pull vector control. And so now if we were to actually select the curve, the circle, you can see that as I move the circle up and down, it's rotating the arm. Let's turn the arm back on to normal. So we can see I can actually control where that elbow is. So now, if I animate my arm using IK, so I'll just bring it down to here, I can also control the position of the elbow, so I can twist it just like that. Constraints are very handy, and using curves as control objects is also a very important part of creating a character rig. So let's look at one more example of using curves and constraints. In this case, we're going to use the look at constraint and some control curves for the eyes so we can control where our character is looking, at least with his eyes. So we're going to go back into our front viewport. Alright, and I'm just going to once again use the circle curve tool here and draw a big circle. Alright, I'm going to template my bones so I can select this control vertex here, this one here, and I'll just scale them inward like so. Alright. I'm just going to go ahead and center the pivot on this object and make sure that it is centered at 0 on the world X there. Now I'm going to do another circle right here for the eye, and in this case I want to make sure that it is centered on the eye itself. So we'll go ahead and hold down V, middle click, and drag it to the center of that eye joint right there. Okay, we can drag it straight out. We're going to duplicate that guy and do the same thing on the other side. So now we want to select these two curves and parent them to this one by pressing P. So now when you move this one around, it moves the other two. Okay, so now we're going to turn on the local rotation axis of these two objects so we can see where they're actually oriented. So we'll select this circle here and go to Display, Transform Display, Local Rotation Axis. So now we can see how this object is actually oriented in 3D space. We can see that its Z-axis is pointing straight ahead, its Y is pointing up. Likewise, we want to do the same thing for this eye here, this eye joint. So we'll go to Display, Transform Display, Local Rotation Axis, and we can see here that the important part is that they are both oriented in the same position. If they weren't, that would be a problem. We'd have to make some adjustments. Alright, so now that we've done that, we're going to select this control circle here, this curve, and then select our eye joint. And we're going to go to the Constrain menu and choose the Aim options. We want to make sure that the aim vector matches the local rotation axis. So we're pointing forward is Z. That's where we want to aim at. So we need to make sure that the aim vector is set to 1 for the Z value. So we've got X, Y, and Z here. So since it's set to 1, we should be good to go. We'll go ahead and hit apply. And sure enough, we didn't see any movement in our joint here. It's still pointing in the same direction. Now, if we had done it using a different vector, so we'll go ahead and try again, constrain, aim, and instead of using 1 on Z, well, let's just try X. Watch, pay close attention to this joint here. If we hit apply, we can see that it moved the I, and the Z also, the orientation changed. So that's not what we want at all. So let's go back to the way we had it. Hit apply. We see no motion. That's good. Alright, so now if we were to select this curve and move it around, we're controlling the I. Alright, likewise, if we grab the main curve and move it around, it in turn controls that eye as well. So we'll do the same thing for this eye over here. We'll select the curve, select the eye, the joint, constrain, aim options, make sure it's set to Z1, hit add. We see no motion, as we should, so we can now control that eye as well. And of course this will control both eyes. Alright, so let's talk about animation. Now, MyLT has a very powerful suite of animation tools, and we'll briefly cover some of them, but what I really want to focus on because of time is motion capture. You don't really need a $30,000 mocap system that's used by AAA studios in order to get some good stuff. These days, a small studio can use one of the more $1,000 range type solutions that uses things like Microsoft Kinect cameras or Sony i cameras in order to get some really good results. So let's pretend that we've got some mocap that we've captured with one of these solutions. And actually, if you go into MyLT Sample Visor under Window, General Editor's Samples Visor, you're going to find some mocap examples that ship with MyLT. So here we have this Fight 1 mocap, and we're just going to go ahead and middle mouse click from the Samples Visor and drag it into the viewport. Alright, I'm going to delete that gun there. Alright, so here we have our guy doing some kung fu action, our motion capture. And if you want to see the actual joints in your models, you can turn on X-ray joints. And now you can actually see the joints there. And what we want to do is we want to retarget this data onto our Sven character. Before we can do that, we're going to have to define the skeleton of our character with human IK, which is what's going to allow us to retarget this data. So to bring up human IK, we'll go to Window, Animation Editors, and then human IK. And now we need to define our skeleton. To do that, we're just going to double click each of these bones inside the human IK interface, and then select the corresponding bone on the character. And you should see it turn green. And it will do that for both sides because human IK is smart enough to figure out that there's symmetry. So we'll just keep going down, selecting each of these in turn. Okay, so we have an all green skeleton here, all green definition. That means human IK is good to go. Alright, so now all we need to do is under source, we need to change this drop down to Fight 1 mocap. And our character is now mimicking that data. Let's go ahead and hide our Fight 1 mocap guy. We'll just go ahead and we'll just shift select the reference here to open it up, and then we'll shift select all of the children nodes, and then we'll go ahead and hide it. Likewise, we'll do the same thing for the mesh. Alright, so now we can see our Sven character is inheriting that animation. Now if we want to, we can actually bake that motion capture data into our character. Because if, for example, if we were to select the joint here on his leg, we can see that even though the leg is in fact animating, there are no keyframes on the time slider here. So in order to do that, we'll just go ahead and select this blue human IK box here, select bake, bake to selection, bring up the options. This all looks good. We'll go ahead and hit bake. And now we can see that if I were to select that same upper leg bone again, we have some keyframes on the time slider. And that is indicated by those red lines. So let's adjust our time slider now so it includes more of the animation range. Looks like it's about 100 frames long. Alright. Now if we want to make adjustments to the animation, there are several ways we can go about that. First of all, we can use the dope sheet to actually drag keyframes around. Now you can simply move keys around on the time slider itself by holding down Shift, dragging to draw a box around the keys you'd like to move. Then you can click on the middle area to drag those keys around. If you'd like to edit more keys at the same time for all the different joints of the body, you can go to the dope sheet. You're going to find this under Window, Animation Editors, Dope Sheet. Okay, I'll select the hip bone in the outliner. And in the dope sheet, we can see the keyframes for the hip joint here in black. And I can select those keyframes here and manipulate them by dragging them left or right, just as I would in the time slider. I can also expand the entire list of joints inside of the dope sheet here. And I can then affect multiple joints at the same time. Another handy tool is the graph editor. This was also found under Animation Editors, Graph Editor. The graph editor allows you to control the interpolation between keyframes. So we can see here, this is the curve for the hips. We have the translate X curve, the translate Y curve, translate Z, and these all correspond to movement along those axes, X, Y, and Z, as well as the rotate for X, Y, and Z. For instance, if I wanted to adjust the X curve, I could come in here and move around individual keyframes so that I get more of a smooth curve. Likewise, if I feel like I don't need these keys, I can simply select them, choose Delete, and see the difference in the curve. Alright, so now let's look briefly at how we could get our character actually inside of the Unity game engine as an animated character that the player can control. Now, I have my fully modeled and skinned and rigged character here in a T-pose that I'm going to go ahead and just send to Unity. But before I do, take note of the material names I've chosen. So in the case of the body, my material name is Sven Body Color. In the case of the hair, Sven Hair Color, and so on. Now these material names should match materials that you've already set up inside of your Unity project. Now, sending to Unity is really easy. Unity supports the FBX file format, and Maya LT has a Send to Unity feature. If you go into the File menu, you'll find it right there, Send to Unity. And we'll call this Sven1 and export it as FBX. Alright, so inside of my Models folder, we'll find the Sven we just imported. And as you can see, he does in fact have all the materials applied to him. So for instance, if I were to just go ahead and drag him into my Unity viewport here, we can see him all ready to go. However, he's not going to animate at this point. He's just a static model. We need to go ahead and add some animation. So let's select Sven in the project hierarchy again and go to the Rig panel in the inspector. And under animation type, we're going to change it from generic to humanoid so we can take advantage of Mechanim. We're going to use the avatar definition created from this model, and now we need to apply, and then we're going to go ahead and configure. Now it may not be necessary to configure your model in this way, but sometimes when you bring the model in, it might have some bones that are improperly matched up. In this case, we can see that my legs, my upper legs, are improperly matched up, so we'll go ahead and fix those. So we'll start with the left leg, upper leg, and we'll just drag the correct bone into that spot. And we'll do the same thing for the right upper leg. Alright, so everything else looks good. We'll go ahead and hit apply. Alright, so now I have a simple run cycle for Sven here, and we're going to go ahead and export this animation so we can use it on our character in Unity. So once again, we'll select the mesh and the skeleton, and we'll just go to File, Send to Unity again, send the selection, and we can call this Sven Run. Alright, so our Sven Run animation is imported into Unity. Under Model, we're going to uncheck Import Materials because we don't need them. Under Rig, we're going to change that to Humanoid. Avatar definition, we're going to create from another avatar. In this case, we're we're going to use the original Sven avatar that when we created the original Sven model. If we go to animations and go ahead and hit play, we can see we have our running animation. Let's go ahead and rename this from take 1 to Sven run 1. You'll also notice that as he runs, he's spinning in a circle, so we need to change his root transform so that it's baked into the pose. Likewise, we'll do the root transform for the Y position. We'll bake that into the pose based on his feet. And now we have him running straight. Finally, we need to create an animation controller for our character. I've already gone ahead and created one inside of Unity to save time. Let's go ahead and open up the one I've already created. So inside of the animation controller, this is basically a state machine for controlling your character's animation. I've added two parameters down at the bottom here, speed and direction. Both of these are floating point values. I have two states. My first state is idle. My second state is locomotion. Now inside the idle state, I've already selected an idle animation that I imported earlier. You'll see that the transition between the idle and the run occurs and is blended into very nicely. And the condition is that the speed becomes greater than 0.5. If that happens, we want to transition from idle to run, in this case locomotion. Locomotion is using a blend tree. The blend tree also has a transition, and that transitions from running to idle. Once again, we have the parameter. In this case, speed is less than 0.5. It should go from run to idle. So we can see my final character here, Sven, in the game. If we select him, we can see that we have our animator, which provides our controller, Sven anim, and our avatar, Sven avatar. We also have a character controller script which goes beyond this class, but there are lots of good tutorials out there on how to set up a character controller script. We also have a scene view camera following script, so basically the camera in our scene will follow the character. Once again, there are lots of great tutorials on the internet on how you can do this. We have our character controller and a rigid body. So when we go ahead and play, here we have our character Sven running in the game. You can see he's making his run left and run right, and then of course when he stops, he transitions to an idle pose. Alright guys, so I hope you've enjoyed the session today. That's about all the time I have left. I hope you've learned a lot about the power of Maya LT in creating real-time game assets, as well as getting those assets into the Unity engine and how easy that is. So we're going to go ahead and open the floor now to Q&A. Once again, thanks for being part of this session today.